Hello everybody, this is Dr. Thunder. Today, I would like to show you how to solve a US high school physics competition question. So we have a particle travel in a straight line. Its velocity as a function of time is shown here. Velocity versus time. So we want to plot the velocity as a function of the distance x from its initial position. So we know in the middle part of the velocity versus time, the velocity is a constant. So that means in the velocity versus x plot, this part is also a constant. So we are not going to give a detailed explanation here. So we only look at this part and that part. So we label this part as 1, and then this part as 3. This is 2. We are not going to explain. It will be a straight line here. So we replot portion 1 here. So we assume the equation for this curve is v equal to ct. C is the slope. So we know that we write it here, v equal to ct. And then we just pick any point here, t for example. And then at this moment, v is equal to ct. And then so we consider from t to t plus, for example here, this is t. So assume we have a very small time gap delta t. We want to see, or instead rather dt. So the distance that is covered during this dt is dx equal to v dt. So that's plug this here. So it's ct dt. So we do an integral from t equal to 0 from t final. Then the distance it travels is x equal to integral dx. That's equal to ct dt. So we integrate from 0 to final t here. So it becomes, this is an easy calculation, it becomes half ct squared. So from here we know that t is equal to v over c, because now we want to derive the relation between v versus x, so we need to get rid of t here. So here, so we plug t into here. So x equal to half c v squared c squared, or half v squared c. So v is, we move 2c here, 2cx square root. So if we plot v equal to square root of 2cx, it will look like that. Yeah. So we can plot this part here. So it looks like that. Now let's look at the portion 3 here. So to make it easier, we start from t equal to 0. So the equation will look like v equal to v0 minus ct. C is the slope, but right now the slope is negative. So here is v0. And then when v is 0, then t is v0 over c. So this point is v0 over c. That's t. So again, we have v is v0 minus ct. So we get here t equal to v0 minus v over c. Again, we randomly pick time t here, and then we pick a very narrow time gap dt here. So we want to see how much distance it will cover during this dt. That's dx equal to v dt. So that v is here, v0 dt minus ct dt. Now we do an integral of x. So x equal to dx, that equal to v0 dt minus ct dt. We integrate from 0 to randomly pick final t. So this become v0 t minus half ct square. Now we plot this here, so it become v0 minus vc minus half c t square, v0 minus v square c square. Now we can eliminate one c here. Then we clean up this term. Then it becomes v0 square minus v square over 2c. So this gives v square is move 2cx, v0 minus 2cx, or clean up 2c, v0 square over 2c minus x. So this means v is square root of this 2c v0 square over 2c minus x. So this, when you plot this, it will look like this. So now we plot this here. So it will look like this. So this is the final plot, and which correspond to answer C. So thank you for viewing. If you like my video, please comment, like, and subscribe.